So hello everybody, my name is Andrej Kish from Think, and today I'm going to talk to you about Glamorous Toolkit and show you a bit what's new, just to see what we've been doing for the last year or so. But before, just as a quick introduction, our goal as Think is to make as much as possible the insides of software systems explainable. And just in 20 seconds to show you what I mean by this, here we are looking at 30 objects. And what we are doing, we are inspecting them and looking at the raw view. So the view that shows us the list of attributes and values from the object. This view is very suitable for understanding how the object is implemented. However, from far away, they all look the same. This view doesn't necessarily tell us something more about the object. A different way is to change the lens through which we look at this. So instead of having always a generic view, be able to look at objects through different domain-specific views. That can help us to give us some more understanding about what an object is or does. And now let's look, next is a demo. So let's look at what's new in GT. So one part that we're looking more at is being able to find code. So we have a class here. This is coder, so we have a class. And we can always look through references. So we can have a view that shows us, okay, this existed before. This shows are all the places in the code where this class is used. So we're finding references to the class. However, we also have documentation. We can have lots of documents in the system. So we have our Lepitor, which is our knowledge base. And then often one question you have is, where is this class referenced within the actual documentation? So this seems to will be happening, seems it's a setup issue, I don't know. It will recover maybe. Maybe I have to be more like this. So for that, for example, whenever we have a class or code, we are able to also look for it through our documentation. So if I look for references in snippets, now we find all the places where this class is used within documentation. And if there is one that's interesting, for example, the squarified, I see here a document called Explaining the Squarified Tree Map Algorithm. I could click on it, and now we can see the document where this class is referenced. So in this case, I think is referenced here. So at any point, if we have a class, we can say, show us all the references of this class in code, but also within documentation, not just code. And this is not only works for classes, and also right now we just show it here as tabs, but we can also do the same kind of searches programmatically. So for example, here it's a small page and I have a method. So this is block closure as a sync future. So this is how we implement futures. It's just one method. I could go on it and say, show me the references or this method. However, we can also do it programmatically. So this will be the same search as if I would right-click here and say browse references. It's just a way to express this search programmatically. And now I get back the list of results. This is nothing new. So we're just looking for references. We could group them by different information, like the package where the reference happened. But then we can do the same actually for documentation. So in this layer comes from Lepitor. So this is our knowledge management system. So give me all references to this method within any documents in the system. So now we get some documents. We can go through them. I don't know, maybe I have here a page. Or we can group them by database. So this is we have different knowledge bases. For example, this is our book. So which are the references in the book maybe? Then I can navigate. And maybe this is an interesting page. Running futures are user background. And somewhere, so for example, here is where we are using this. So when we search for code and methods, we can either from the UI or programmatically find references in both code and documentation, so not just code. And if we go back, it's also possible, for example, since we can express a filter as code, to create composable filters by programming. So in this case, I might want to say what I did before. Find all references and just shows the one that are in the GT book. So now we just got the same as before. So filters can be combined often programmatically, so we can narrow the scope if that's what we want to do. And OK, we can find things, but what happens when we rename things? Because often we write documentation, and then we rename our code, our methods, our classes. What will happen then? Usually documentation again gets obsolete. And we have to use find and replace, maybe. So let's see what we can do about that. So maybe I realized I named this class incorrectly. I want it to be named with a capital M. So I can rename it. Now I will accept, I want to accept, and now I will get a refactoring. And if I look at this refactoring, it tells me it's going to do 21 changes. I can expand, and I have, for example, here there are some method changes. In this case, it's going to change the pragma. However, if we look down, it also has snippet changes. So it finds the references of this class in all documentation and adds all the changes to the documentation as part of the refactoring. So we can see here that it's going to change the reference to the new one. It's going to do it, for example, here in text, but it also does it in all code snippets. So if you have also code snippets in documentation, it finds references within those. So now if I will accept this name here and this name here should be updated. It's executing, and now I have my new name here. So my code was kept up to date as I rename this. And it's the same for methods. For example, maybe I would just like to rename this method for some reason. I want it to be called Lepiter references. Maybe I could come here. I could say I want to, where is, rename, Lepiter. Lepiter references. Now I will have, I don't know, 18 changes. And again, most changes here are in snippets, I see. So again, I will execute, and then this will go change both code and documentation. So now I have my Lepiter references. So like this, we're trying to help us keep documentation more in sync, but not having to always manually do it, update classes and methods as we rename them. Now, another interesting thing in GT is that GT, we try to make it a bit more async. It's still one processor, but we are having the user interface that runs in a process, and then we try to run all other computations in other processes at lower priority. So then we don't want to block the UI process. The UI process receives says, I'm starting the computation happens somewhere in the background, and then after it's done, we get the results, and the UI process updates. And this model means we're going to get a lot of processes. Still just one executes at a time, but then we have computations that are spread out across multiple processes at different priorities. And ideally for the UI, we still like to keep one frame at 64 milliseconds. So have 64 milliseconds per frame. And one problem we had is how do we profile this? We can use message tally, but there is not always precise enough. We don't know which process was executing at which time. Was a process blocked on a semaphore? What was it happening? So we try to address that. We use a slightly updated version, tweaked version of the VM that records whenever process switches happen and whenever processes are locked or waiting on semaphores. So we can get this information from the VM. And then we can do very fine-grained profiling and see exactly which processes are doing what at what time. So let's just profile first one use case that we have often is that we have an editor and I'm typing something. And I want to profile what happens when I type. Just exactly these few milliseconds. And you see we have so when you type, lots of things happen. The code gets restyled, widgets can be added or removed. Here we have this, so many things happen. So the editor actually has a list of stylers that are applied whenever the code changes. And often maybe one styler takes 50 milliseconds instead of 5, or it's this thing. So we want to be able to understand. So for that, what we can do is start a profiling for, in my case, 10 seconds, do the action that I'm interested in within those 10 seconds, and then we can look at the result. So let's do that. I started. I have 10 seconds, so I don't have to hurry. I'm going to type one character. And now we have to wait the remaining time. We will get here a notification. I already have one because I did this before. It should say 2. Perfect. So now, okay, telemetry finished. And when this is finished, we can inspect the results. Yeah, we had 25 active processes during this. And now if we go to this view, now we process the information. And now we can see what are all those processes, and each process what it did. So for example, this is the idle process. So when this is active, nothing happens. So the execution gives control to, the VM gives control to the idle process when nothing is happening. But this is the UI process, so we see it did some things. And this is actually the worker, the future workers, the one that, the stack styler. So this is the process that did the styling. And here, whenever you see a blue, it means the process was executing at that time. That process had control. Only one process will be at a time, because it's not parallel, it's just, one process can be active, but then we're able to see exactly which process was active when. So if we select this process, for example, let's do this. Let's find these computations view. So we can see this, we had three tallies for this, and in this case, it did 33 milliseconds of computation. And for the styler process, because it's special, we have some extra information. We can expand it, and for example, we can see for each styler how many seconds or milliseconds or microseconds it took. So for example, this is the styler that in our case has the triangle to expand methods. It took 3 milliseconds. The highlighter took 400 microseconds. So we're able to see exactly what part of the computation happened at microsecond level. And so this is quite useful when you have this small UI process that does for 64 frames per second, 64 milliseconds, 60 milliseconds, 64 frames per second. So we really want it to be fast. We can see exactly what is happening. And let's do one more complicated profiling. So I'm going to start the profiler, and now just create some elements. So I'm going to click around a bit. So we get a bit more activity. OK, it's finished. Now we can process the event. We get, again, timeline. And now, for example, we get more. And we also get some red. Red means that process was waiting on a semaphore. So somebody said semaphore wait, and then this process is waiting on a semaphore. To see more, we can always go into it and go into the logs view. So this is showing the time intervals, because there can be more, when the process was waiting on a semaphore. So here there are two red parts. So you can see that for 30 milliseconds and 11 milliseconds, this process was blocked on a semaphore. And if we dive in, we also get the stack trace of where that happened. So in this case, it's exactly at this point. So we had, I don't know the details, they vary, but it's very useful, because then you can see exactly the place where your process was locked on a semaphore and for how long. And then usually you look for another process that was executing at the same time, because probably that's the process that was doing the computation. But we don't have that information yet. But overall, this kind of looking at things was very useful to see what is happening in the system, especially for short period of time of a few seconds when you are not sure and you like to know what is going on. Another very small thing is that sometimes we have to deal with big images, and we need to have memory leaks. And then we need to find references. Pharo has the reference finder, which is nice. However, if the image is a bit bigger, it tends to be slow. So here we have just an instance counter. So we're going to take a few seconds, and we're going to see how many instances we have, how many objects we have in this image. Should be 30 million, maybe. It still takes a bit, because I've been playing with this image for a while. So it will. It's still thinking, so I must have a lot of objects. Sorry? Your profiling data maybe. No, it's not that big. 61 million objects. OK, so there are quite a few. And we usually have to deal with images that might be 10 times bigger than this. So they can get huge. And then you have a memory leak. We have to find all references from one object to the root. So with the normal reference finder, we waited hours sometimes, and it doesn't work. So we have another one that's implemented as a VM primitive. We have a memory of the VM in Rust, so we can traverse it in a faster way. So now this is the standard one. So we're going to say, find me the reference to the first instance of tab group, and it's done. So sometimes with the normal reference finder, it can take 10 to 100 times longer, depending on what happens. This is nice, but then often what we want is have a bit more information. So we want to say, find me all references now, not just one. Maybe there are more paths to this object from memory, and I'd like to get an idea of what those paths are. And also look a bit differently. Here we just get the list of objects, but we'd like to know a bit more information. For example, how are these two related? So we have parallel universe. How is the connection between these two objects? I just get the list, but what's the actual connection? This will take a few seconds. This is a bit slower, especially that I have a ton of objects. But you have to imagine this is small. Multiply the number of objects by 10, and then it can get slow. Should take a few seconds, hopefully. Same as counting the memory, usually. Because counting the instances above actually traverses all the objects and just gets which type are. We're going to wait, because, yeah, still takes a lot. It's still not magic, but last time, I could not try this with the reference finder, because then we stay here the whole presentation. But then it's done. So now it found 158 paths that this object is referenced through, which are quite a lot. And if we want to know more information, we could select one. And first, we have the whole path. So this is exactly the list of all objects. And we also get exactly how one relates to the other. So we can see here, we have an object that's parallel universe and has a value. That's another parallel universe, which is the class. That has a class pool that has a dictionary. The dictionary has an array, then an item in the array. So we can see also at object attribute. So we have an object, and we know which attribute then points to the next object and to the next. So we can, we don't have to guess what's the relation between these. And then at the end, we have the object that we had. And we also have a view where we remove all the noise, because we don't care initially that, okay, we know that it's small talk, system dictionary. We don't need array accesses because they are boring. So this is like a condensed view of this path of who references this object. And this is extremely useful in debugging memory leaks when the image grows to more than 10 gigabytes, for example, to see what's going on there. And next, as I said at the beginning, we like views. So the way we interact with object is by creating views. And what we try to do is make it as easy as possible to create views, or try to reduce the effort that people could use to create custom views for their objects. So let's just see an example. I have here a small class that does a request to GitHub and gets the list of open issues from gtoolkit, from gtoolkit repo in the FinCom organization. I already executed it, so I don't have to wait. It takes a few seconds. So we get this. So we can see we had 321 issues. And now, okay, I have the raw view. I could maybe go in open issues, look at this, but ideally, I would like to have here a view that shows me the list of issues. Simple. I can right-click. And then when we right-click on an object, depending on its type, we have templates that match to the object and say, these are some possible views that we can create for this object. And in my case, the first one says, I want a column list. So this is an array, so we can display it as a list. OK, maybe I want, looks good. Maybe I want to edit it, so we can edit it in place if we want. And OK. And now it created a new view when I have my view without doing any coding. I can select one. OK, I have my issue. OK, this has a raw data. OK, I can select it, and I can see it here. But OK, maybe here, here. But I would still like to be able to navigate. Now, next one, and it's complicated. Yeah, why not create a view here showing the items? We could right-click. And we also show all the views that the object has that we select. And we say, maybe you want to forward to one. Just reuse it in your context. Yeah, the raw data looks good. Maybe I want to edit it a bit. Done. So now I have a small demo, a small browser that I can do. I created two views without almost writing any code or using any AI. There are templates that we can match, and based on those templates, we can show relevant views for that object. And also, we try to make it easy to edit these views. So here, for example, this one says demo GitHub issues. I don't want to. I just want to show the title. So I would like to edit the view. Before, you could alt-click on the, for example, I'll do it here. I can alt-click, and then I get the source, but that opens a new pane. And sometimes it's annoying. What we can do is, for example, right-click. I look at the defining method. I could edit. I can also drag it around. So now it's kind of a persisted object in the flow. So if that's what I want, it doesn't stay. It just goes with the flow. Now I can do my, maybe how do I show the title? Maybe I can go here, Do I have a, let's move it around. Yeah, I have a title. Okay, so maybe I want title here. So yeah. So like that, we can kind of do a live development of views while also exploring and having the code inside. And this can be done, this kind of pop-up for lots of other things in the UI. You can just pop up and keep them around in the flow, and they move with the flow. And let's just add one more view. I have here the issues, but I would like to see them grouped by users. Let's see who creates the most issues in GT. So I have some code. This says I want to just group them by. So I just want to do a group by. And yeah, I have the value, but okay, not ideal. So maybe I executed the code. I have an object. I could right click. And now based on the result object, we can have different views that are relevant for, in this case, we have an array that has arrays. So a dictionary with arrays. So in this case, we show a grouping. We detect that we could show a grouping of those. So I will just accept it, and now we have grouping, but maybe I would like to reverse it. So let's put here, I think it's greater. So yeah, seems that I'm the user that creates the most. And this can also be visual, so I will just do a grouping using a bar chart. So now I have this view. So in this case, you can create views of objects in a more fun, experimenting around, seeing what works, and don't have to necessarily know the API, just by matching templates. Okay, a bit more to change the topic. Also, we played a bit more with transformations, code transformations, like transforming Delphi to C#. And I just want to show you an example of how we can do that. I have some code here. This code is just some Delphi code, more or less. We can always parse it if we want, and see the AST and browse through the AST and do things like that. But we can also, we have a file with rewrites. So we have a file that says how should things be transformed. Okay, manually written. So we can see a node, and we can see, like, I don't know, program file node, or maybe we have a variable node, and this is how this is going to be translated. Here I'm just looking at the file reference, the object, but then because it's a rewrite, we can attach a different interaction. We can also edit here and then save the content of the file if we want to. But now let's open the tool for transformations. So the tool, I can see all the files that I have loaded. I could select a file and look at it. I also have the list of transformations that we looked at before. This is just the file. And I could click on any file and say preview. Show me how you're going to transform it. So now this is the Delphi, and this is the C#. And if I'm interested to know how was this class transformed, this shows us the rewrite rule that was applied on that node. And if I select it, I go to the rewrite node that was applied. And maybe you notice here a debug button. This is the interesting one. I have to exit full screen mode because it will open tabs. So now, for example, we're going to get a debugger to debug the transformations. So I'm going to step through, and this is the initial code. And this is the Delphi, and this is the C#. And still, if you notice here, this is still Delphi code. And this is C#, so this was not transformed yet. So now I can step over, and if you look here, you will see live as the transformations are applied on the output. See, it changed. So it said I'm going to remove that, I'm going to remove some more things, and I'm going to add a curly brace. So now it lively did a transformation, so I could lively debug what's happening. And we can go maybe to the next node, this one, now to the rewrite of that node, and see how this attribute is being rewritten. So yeah, it rewrote it. So like this, we can lively debug transformations and see what's happening. They don't have to be a mystery or a black box. And talking more about languages, we also like to play, we had to play with CSS. So we have projects that have CSS. We can also have CSS. So this is a project where I loaded some CSS. And of course, we can have syntax highlighting. We also have completion with the language server protocol. So I don't know. But we get all the completion in whatever you get in any IDE. I don't know. What can I put here? I don't know. So yeah, completion, I broke something, doesn't matter. But more interesting is that, how do I find references? So I have this, for example, here. So I like to say, find me all the references in CSS for this one. So then I can see its reference, for example, here. And also in this case, we are using them in code by putting the string. So I can also find me all the places where this is used in code, more or less. So now I see that this link here has been used in this place. And of course, if we can find, we can rename. So now I want to rename the CSS class, maybe name it link2. I don't know. So now I get a refactoring, and it's going to find all the CSS files and also all the string places. So in the same refactoring, it's going to refactor two things. So I will accept, and now it changed it here. And now if I look for references in CSS, it also changed it here. So it managed to find both strings and CSS selectors and replace it in both. And yeah, this is something else we've been playing with, more in the context of CSS at the moment. And last but not least, and this is my last part of the demo, also showed a bit in the presentation before, we have AI assistants. So we have an integration with AI, and it's possible from within GT to send prompts and get back results. So let's just do a very quick demo. I already have a prompt prepared. Where do I write the prompt? I could write the prompt directly in the playground, because I have it. And it's a comment, and if we put a colon, you will notice a button, and it turns into a prompt. So now if I click this, I'm going to send this prompt to an LLM. In this case, ChatGPT 4.1. And I'm asking it to give me the code to get the data of the ThinkHome organization from GitHub. I already did some interaction before to make sure it works. So I could inspect the chat. I get it in place. I could also inspect it. And now I get the result. When we get the result, sometimes we get both text and code. And whenever we get code, we can execute it in place. Why not? And this is the response. We can know its code, we can style. So this is, for example, makes a Zing request. I don't like this one. I don't want to inspect it. So I can edit the code right here. I don't have to go to any other tool. And now I can execute, and I'm going to get back the list here. And let's do one more query here. So I want to have a class that is wrapping this now. I just want to create a class to put this org data in a class that has this data. I will copy my prompt. This time I'm writing it in the chat, and I'm sending it to the LLM. Hopefully it doesn't think too much. Sometimes it thinks much. Sometimes it goes quite fast. And ideally, I expect a class definition back and some methods, because that's what I asked for. Take your time. OK, super. It got a result. We see. So in GT, we still use Pharo 11 for the moment. So this is the old syntax. We got some methods. We got a view. We got some usage code. Interesting. Now I could copy-paste this code, or we can extract the code and just show it. So this was the code. Or we can also create a transformation directly that is going to apply this code, and then we can see the diff with the current state of the environment. So in this case, just apply everything. Let's not spend too much time. And now let's go to the text. And now we should have the snippet to instantiate. I have no idea how this is going to work, so let's execute it. Again, we can execute it in place. And it didn't work as maybe I need to return the organization, my guess. Perfect. So now I got my organization, and this organization has my data and also generated a view. In this case, the AI generated a view instead of me. And just to show you, 1 minute to show you a bit what's here. So if you see, we have a list of messages. Each message is an object. I can inspect the message. And also, if you look here, I have some actions. Explain snippet, propose code, propose actions. These are specific to this assistant. If we look in the chat, I have an assistant. So the chat is generic, and it has an assistant. And it has a code snippet. And the assistant is the one that has actions specific to this context. And to show you more, if I come back to the object we previously had, OK, this was not saved, so I have to put org again. And I say I'm interested in this object. Maybe I'm interested in this method. I could start an assistant on this method. And now this assistant has actions that are specific to the method. Or I could start an assistant on the class that has actions that are specific to the class. So these are prompts that are already there that I can add more information to if I want to. Or I can just spawn an assistant directly on the object. And then, again, the actions are different, and in the raw view, this has a different assistant. So object assistant, method assistant, class assistant, snippet assistant, different types of assistants with different type of domain-specific actions. So instead of necessarily having a global chat as the entry point are little assistants that you can spawn from the tools as you need them. Okay, and maybe 30 seconds to show you that this can also be done visually. So we have here, before we just looked at code, but maybe I want to create a wordly map. This is just some kind of visual map to make business decisions. So let's just ask the assistant now to give us. I could also open the assistant, maybe you can see what happens. This is the assistant, but I don't have to open it. I would just like to say to generate me a map on software development in the presence of LLM. Yeah, finish. This is my last. So now the same assistant. I have this assistant is specific for wordly maps. If we look at formats, it understands what a wordly map is and how we should give it back to us, and hopefully, yeah, it asks for a confirmation, but hopefully, if this is going to work, we'll get back a wordly map. So it will not be something just that's textual, it will always be something that's also more visual. And as soon as this is done, I'm done with my demo. So let's hope that the LLM is not taking too long. Or in case it gives out the map, but I see it didn't want to update the thing. Okay, we can stop here. So it gave us a map. I don't know why it decided not to put it in to update the view. Sometimes it has a mind of its own. Yeah. Thank you very much.
Are there any questions?
For the CSS classes, how do you find the references to the CSS classes? I'm asking because I'm having the same issue and I use just a finder.
We parse the CSS, we have a parser, and then we build a model for so we have the model for the CSS, and then we can search at the CSS level, like in classes in Pharo. I guess if you have more questions, you can find me around, as I went a bit over time.
Yes, because we kind of extended the time for this part. So if there is only one more question, we can allow it, and then we should proceed with the other presentations. Thank you.